Okay, here's a good problem for you to try. Number 6. See if you can tell out of these 6 graphs, A, B, C, D, E, F, whether or not the graphs represent a function using the vertical line test. Using the vertical line test. Press pause, write your answer down, and then come on back and I'll share my answers with you. Okay, welcome back. A, yes, it is a function. So yes, a function. Maybe I'll just put function there. And then on B, I also got that's a function. On C, not a function. This fails the vertical line test. So when we take that vertical line and we pass it through the graph, it passes right there, but then it's going to fail immediately. And if it fails anywhere, then it's not a function. This actually fails in many different places. So just not a function. And then D, well, circles, those aren't functions. They fail the vertical line test. E is a function. We graphed a couple of these in the previous video. And then F, while it passes here and it passes here, it doesn't pass there. And as soon as it fails, it is not a function. Not a function. Okay, let's look at number 7. Determine the interval in which the graph is increasing, decreasing, and its max and min value. So these are the points that are important for you to graph. -1, -1, -2, 0, 1, -2, and 3, 2. Those are important points for you to graph. Make sure you draw and then come on back because we're going to start doing this problem. Okay. Now, I'm going to draw over this curve with my gray pen. Going from left to right, starting at the leftmost point, my graph is going up, and then it's going to turn and start heading downward, and then it gets to this point right here, and it's going to turn again, and it's going to go upward. So a graph is increasing. It's considered to be increasing when x increases and y increases. So if x and y are both increasing, so as x increases, y increases. That means that the function is increasing at that point. Okay. Decreasing, I always go from left to right. So decreasing happens when, as x increases, because we're always going to go from left to right, so that means that x is going to be increasing all the time. When x is increasing, y is decreasing. So they're not working together. So that is a decreasing portion of the graph. And then a max value is the maximum y, value. And a min value is going to be the minimum y value, the smallest y value on the graph. The biggest y value on the graph and the smallest y value on the graph. So as x increases, so we start at x equals -3. As x increases, y is increasing right here. As x increases, y increases. So this green portion of the graph is an increasing portion. But then you see right here at this point, the graph turns. And as x gets bigger, now y is going to, instead of continuing to increase, the y value is 0, it's getting smaller. It's going down to -2. That's a decreasing portion of the graph. And then we have a turning point because x is going to continue to increase, but this time y is going to start getting larger again. So when it asks us for the increasing interval happens from -3 to -2. And then it happens again at +1 to +3. So increasing interval is -3 to -2 and from 1 to 3. Now, increasing and decreasing intervals will always be open. Always open intervals. Always open intervals. The decreasing interval happens from -2 to +1. So the interval at which a graph is increasing are the values in the domain in which x is getting larger and y is also getting larger. And then decreasing, again, that interval is the interval of x values in which as x increases, y decreases. Now the maximum y value and the minimum y value on this problem, the lowest y value is going to be -2. So that's a minimum. So the minimum equals -2. And the maximum y value is equal to +2. +2. So that's everything we have to say about that problem right there. Let's highlight it. I think that's what they want us to find, the max, the min, the increasing and decreasing intervals. Okay, number 8. Let's see if we can do this one. You try and do the increasing and decreasing intervals. And then we'll talk about the max and min. Okay, press pause so that you can do that. Now it looks like this graph is going to increase. As x gets bigger, it's going to increase from left to right until we get to that point right there. There's our turning point. So it looks like there's an arrow on the end. So that means it's going down and to the left forever. So -infinity to -2. And then it's going to turn. We've got a turning point there. It's going to turn and it's going to start decreasing. It's kind of like a roller coaster ride. So it's going to decrease from -2 to +1. And then it turns again. It's got that turning point. And it's going to increase. And then it just keeps increasing the further we go to the right. So it's going to increase from +1 to infinity. So in case you couldn't see that, from -infinity to -2, it's increasing. From 1 to infinity, it's increasing. But from -2 to +1, it's decreasing. So increasing, decreasing. So there. So increasing from -infinity to -2, comma, 1 to infinity, and decreasing from -2 to 1. Now it's max and min values. You might think, oh, well, those pink turning points are max and min values. This would be considered, this pink value right here, where we go from increasing to decreasing. From increasing to decreasing is usually a maximum. However, in this case, there is no maximum because we've got the graph going up to infinity, so it never reaches a maximum value. This is called a relative maximum. It's not the global or the overall maximum, it's a relative maximum. So the relative maximum, relative to just like a local, maybe a local maximum or a relative maximum. I'm going to put local here because we also call it a local maximum. Just local to that area. The relative or local maximum, 1, 2, 3, 4, would be 4. And then this point right here where we go from decreasing, right? We went from decreasing to increasing. Decreasing to increasing is where you have a turning point that is a minimum value. And that as well is a local or relative minimum. And that's because this graph really goes down to negative infinity. It doesn't have a minimum value, it just keeps dropping. It drops forever. So the local or relative minimum is -2, that y value. So remember, your maximums and minimums are your y values.